So what we're going to be looking at here today is we're going to be looking at elementary matrices and row reductions. We'll talk a bit about what elementary matrices are, but essentially what they do is they transform elementary row operations into matrices. They're going to allow us to use matrix algebra to do row reduction. They'll even allow us to do things like use inverses in order to represent kind of like taking a matrix and inverting its row reduction. And they allow us to represent elementary row operations as linear transformations. What we're going to do is we're going to actually develop a really handy decomposition called an LU decomposition that will break down any kind of invertible matrix into a series of these elementary matrices. So follow along. It's a little tricky to kind of work through, and what you're going to want to make sure is you're going to want to make sure that you've done some matrix multiplication, that you've done some row reduction, okay, and that you feel comfortable with both of those things because they actually are really important for understanding elementary matrices. So what we're going to be looking at now is, well, let's look at the elementary row operations and let's define them, and we're going to use some notation here to help us define them before we transform them into actual elementary matrices. So a permutation is going to be switching one row with another, and how we're going to represent that is we're going to represent that as Pij. And Pij basically means we're going to switch the ith and the jth row. So an example of this would be P12, where we switch the first and the second rows. Okay, just do that permutation. The second is going to be row multiplication. And row multiplication is going to be, we're going to be multiplying a row, and let's be the ith row, by the scalar k. Okay, so that'll be by a scalar k. So we'll multiply row I by the scalar k. So for example, we might say, okay, let's multiply the third row by the scalar -1/2. Oftentimes we're going to do this in order to transform a non-1 or non-leading 1 into a 1 so that we can continue doing elementary row operations. Next up, addition. We're going to be adding k times row I to row j. And so we're going to have A is going to be how we represent it, and it'll be Aij k. Okay? And how you'll sometimes see this, or how I write it oftentimes, is it'll be like, say for example, it'll be row j minus k times row I, or plus k times row I. And that's how I'll oftentimes write it when I'm just doing row reduction. So if you've seen this kind of symbols, we're going to rewrite this as Aijk, and I'm going to do a little bit of that as I'm working. Okay? So for example, we might say add 2 times the first row to the third row. Okay? And what will happen is this is going to go in the jth row. So we're changing the jth row here. Here we're changing the third row. So the row that's being changed is the second value. It's that jth value when we talk about our elementary operations. So those are our 3 operations: permutation, row multiplication, and addition. Let's take a look at how we're actually going to go in and represent them as matrices. If we start with permutation, a permutation matrix is essentially going to be the identity matrix. So we'll start out with the identity matrix. Say, for example, we've got a 3 by 3. And what we're going to do in a permutation matrix is we're going to permute the columns. We're going to actually permute the columns and inside of that permutation matrix. So for example, if I wanted to permute 1 and 3, that would actually be this matrix. It would be 0, 0, 1, 0, 1, 0, 1, 0, 0. And so what you could do, you could actually try this out. Let's say, for example, we take the matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. Go ahead and pause for a second and see for the fact that you're actually going to end up with 7, 8, 9 on the top, 4, 5, 6, and then 1, 2, 3 on the bottom. So what will happen here for P13 is we're actually going to permute row 1 and row 3. Take another example. Let's say, for example, we take P12 and we want to do it in a 2 by 2. So we've got 1, 0. We would start out with 1, 0, 0, 1, and P12 would then switch those columns. And if you went in and actually multiplied that by, say, for example, 3, 5, -1, 2, you'd see that you'd get -1, 2, 3, 5. And so go ahead and pause for a second and see that that's in fact what you get with the multiplication. So with a permutation matrix, what you're going to be doing is you're going to actually be switching the ith and the jth columns, and that allows you to switch the ith and jth rows. Now let's look at multiplication. So multiplication, we're going to start with the identity matrix and place the scalar in the ith row. So what that'll look like is, say for example, I take M2 and I've got -3. And let's say that we're working with 4x4 matrices. So my 4x4 matrix is, we're going to have 1, 0, 0, 0, and then 0, and in the second row we're going to put a -3, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. So you'll notice we're going to place the scalar into the ith row, whatever this row is, okay? And everywhere else we're going to have a 1 along those diagonals. And you could see if you went in, say for example, you multiply by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, -3. So it'll be -15, -18, -21, and -6, and -20. And that'll be your result. So take a look at another example. Let's say we multiply row 3 by 2. Multiply row 3 by 2, and we'll look at this as a 3 by 3. So we've got 1, 0, 0, 0, 1, 0, 0, 0, 2. And if we were to multiply a matrix, say for example, 4, 0, 0, 0, 3, 0, 0, 0, 5, the first two rows would remain exactly the same. You can go ahead and stop your video for a second and watch this. You'll get 4, 0, 0, 0, 3, 0, and 0, 0, 10. And that will be the result. We've multiplied that third row by the scalar 2. Now our last one here is addition, and addition is a little bit trickier. What we want to do is we're going to start with the identity matrix, and then in the j'th position, we're going to place the scalar k. So let's say, for example, I want to take row 2, and I want to subtract 3 times row 1. Okay? And so what we'll write this is going to be a 1, 2, -3. a 1, 2, -3. That's how we actually write that. So our elementary matrix, that's going to end up equaling, okay, let's imagine that this is a 3 by 3. We're going to have in A21, we'll have a -3. So we'll have 1, 0, 0, and then -3, 1, 0, 0, 0, 1. And that'll be our elementary matrix. So what we'll do, let's say for example we go in and we multiply this. We'll multiply it by 2, 1, 0, 0, -1, 3, and 4, 1, 2. What you'll see is that the first line doesn't change. The third line is not going to change. What's going to happen is we're going to get a change to the second line. We're going to take -3 times 2 and add it to 0. So this will become -6. We'll take -3 times 1, that's -3 plus -1, that'll be -4. And then -3 times 0 is 0 plus 3, and that'll end up giving me 3. And so what you've seen here is you've seen that we've gone in and we've added -3 times row 1 onto row 2. And that's what that elementary matrix is going to do. Let's say, for example, we choose another example. Let's do a 2 by 2. And let's say we have row 1, and we want to add to it 1/2 row 2. So this is going to be A21, 1/2. Notice that in terms of our notation, the second one, the one that's going to be getting added to, is going to be our first value, and then we have the 1 is the second. Now what we'll do here, since this is a 2 by 2, is we're going to put into A12, okay, we'll put the 1/2, so that's going to be 1/2. Then we're going to have an identity matrix everywhere else, and so that'll end up being our elementary matrix. We go in here, let's say we take 1, 2, 3, 4, and what we should expect to have happen, we got 1 plus 3 halves, that'll end up being 5 halves. We'll have 2 plus 2, that's 4, okay, and then the second row should remain exactly the same, 3, 4. So we've gone in and we've added 1/2 times our second row plus our first row, and that's our addition matrix. Let's do this one more time, kind of give it an example again. So let's say, for example, I want to do row 3 minus 2 row 2. So that's again going to be A23, because 3 is the one being changed, 2 is going to be the one we're adding, and then we'll multiply that by -2. And our matrix, let's say it's a 3 by 3 now, is going to be, we got 1, 1, 1, okay? And then in the A32 spot, so third row, second column, we're going to put a -2. and that'll end up being our elementary matrix. And what this will do is this is going to go in and it's going to add -2 times the second row plus row 3. And into row 3, excuse me. So let's take a look at an example. And let's say we want to use these elementary matrices to do row reduction. So we're going to find the RREF of A using elementary matrices. We're going to row reduce it down to the reduced row echelon form. So what I've done here is I've actually gone in and I have done the row reduction. And this row reduction also includes the elementary operations that I've used. And so I've drawn a trace of them. That's basically what it's called. It's called the trace of the elementary row operations. And so you'll see I started out with 2, 3, 5, 1. And then I multiplied row 1 by 1/2. And I highly recommend that you go in and you, instead of basically doing your row reduction where you're kind of taking multiples of one row and multiples of another, you can't really do that with elementary matrices. So transform all of your leading ones, all your pivots, into actual leading ones. So we've got multiply row 1 by 1/2. And we did that, and now I come up with this second matrix right here. And then with the second matrix, I'm going to take row 2 and I'm going to subtract 5 times row 1. And my elementary matrix is going to be A12 -5. We'll transform that in just a moment. Then I have 1, 3/2, 0, -13/2. Okay, that's my result. And so I'm going to multiply row 2 now by -2/13. Then I need to actually zero out above the 1 in my row reduction. So I'm going to go in and I'm going to add -3/2 of row 2 to row 1. So I got row 1 minus 3/2 row 2, and my elementary matrix is going to be A21 -3/2. So what I'm going to do with this is I'm actually going to start out with the matrix that I began with. And that's going to be 2, 3, 5, 1. Now what you're going to see here is you're going to see that we're going to multiply our elementary matrices on the left-hand side. So notice when I was doing it, I was giving examples, I multiplied my elementary matrices on the left-hand side. We're going to do the same thing here. So my first elementary matrix, right, is multiply row 1 by 1/2. So I'm going to have 1/2, 0, 0, 1. That's my first matrix. Go in and do that multiplication, and you're going to see you're going to get 1, 3/2, 5, 1. The second matrix, and we're going to left multiply, now those two matrices, we're going to left multiply again. And remember in A21, we're going to put that -5. So that's actually going to be -5 here. We have 1 and a 1 and a 0. And that'll get me to the third matrix, or the third piece of my row reduction. Then I'm going to go into multiplying row 2 by -2/13. So this will be 1, 0, 0, -2/13. And finally, our last operation is going to be A21 -3/2. So remember, we're going to put the -3/2 into A12. So there's the -3/2 right here. We got 1, 0, 0, 1. So this, by the way, will end up equaling 1, 0, 0, 1. So if I rewrote this, my matrix A, we'll let this be the matrix A. So I'm going to have A times, and on the left-hand side, we took M1, 1/2, multiplied A12, -5 on the other side, then M2, -2/13, and then A21, -3/2. And this ends up equaling I 2 by 2. The identity, the 2 by 2 identity. So that's basically like what it would look like to go in and use elementary matrices in order to do row reduction. So let's take a look at a second example. And with the second example, you'll see we've taken a 3 by 3, 1, 0, -1, 1, -2, 2, 0, 1, 1. And what we've done is we've gone in and we've row reduced it, and I've included the trace of all the row operations that I used. So where we're going to start is we're going to start with our A matrix, okay? And let me start far enough over. And that'll be 1, 0, -1, 1, -2, 2, 0, 1, 1. And we'll left multiply then by A12, -1. So that'll be 1, 0, 0. The -1 is in 2, 1. 0, 0, 0, or excuse me, that's a 1, 0, 1. And that's our addition matrix. Then we have our permutation matrix, P23. So we're going to get 1, 0, 0, 0, 0, 1, 0, 1, 0, and that'll be our permutation matrix. Then we'll go in, we'll do A232, A232, so that's in slot 3, 2. We're going to put a 2, so that's going to be 1, 0, 0, 0, 1, 0, 0, 2, 0, 0, 2, 1. So an identity matrix, and then in A32, we'll put the 2. Next matrix, multiply row 3 by 1/5. So we're going to get 1, 0, 0, 0, 1, 0, 0, 0, 1/5. Then we're going to go in and we'll do A32 negative 1. So that's 2, 3 is going to have a negative 1. So there's 2, 3 right there. And then 1's along our diagonal and 0's everywhere else. And finally, we have A3, 1. So in 1, 3, we're going to have a 1. And then 1's along our diagonal and 0's everywhere else. Okay? If I rewrite my trace, I'm going to write that as an equation. I've got A here times, and this will be A12 negative 1, P23, A23 2, M3 1/5, A32 negative 1, A31 1. And that is the trace, and this will end up equaling I 3 by 3. So that's how actually we rewrite row reduction utilizing these elementary matrices. We're going to do another video in just a little bit, and in this next video what we're going to do is we're going to be looking at how do we actually go out and write A as a series or a product of elementary row matrices. Right? It's really not all that hard. It's actually pretty simple, but we're going to have to find a way to reinterpret each one of these matrices as their inverses. Okay? So this finishes up this video on doing row reduction using elementary matrices.